Hi there once again and welcome to another Espresso Mechanic tutorial. And in this one we're going to be building what you see on the screen. And I'm doing this particular video as an episode of Espresso Nuts and Bolts because in order to achieve this we're going to be making use of the reference node, which is a node I've never used before in any scenario. So it's one we've not looked at before. Now, it's going to be a slightly longer tutorial than most of the nuts and bolts tutorials because the expression is actually considerably larger than I thought it would actually turn out to be. But anyway, that's what we're going to be about in this tutorial. So without further ado, let's see if we can make this happen. We'll start by bringing in some objects. I'll bring in a cube, make it 20 by 20 by 20, put a little bit of a fillet on it, just 0.5 centimeters will be fine, I think. 0.5, and then I'll move this along its z-axis to 100 or minus 150. Minus 150, that's where it needs to be. I'll bring in a cone, make it 10 in its bottom radius, 20 in its height, and move this to 150 along its Z axis. What I'll also do with both of these is move them up 10 so that they're just sitting on the floor, just for the sake of making things tidy. And then we can bring in a couple of other items. We'll bring in a pyramid. We'll make this 20 by 20 by 20. Again, we'll raise it up 10, and this time along the x-axis we'll make it 150. Finally, we need to bring in a cylinder, 10 in the radius, 20 in the height, 20 or 10 in the coordinates on the y-axis, and minus 150 in the not in the z. We want it along the x-axis, so minus 150. And there we go. We've got our items set up and ready to go. Moving on from here, we need to bring in a circle. We need to set it along the XZ plane, and then we need to think about adjusting its radius, and that needs to be 120. The final object we need to bring in is of course a sphere. We will make this 10 in its radius. I'll also move the circle up 10 in the Y axis, and then what we need to do is give our sphere an align to spline tag, and the spline will be the circle. Now at the moment it's aligned with the pyramid. Don't really want that. In fact, what I'm going to do, looking at it, my cone ought to be swapped with my cube, so to make this exactly as I did before, and I want to do that, I'm just going to make that 150. And then we need to reorder as well, because I want my cone to be the first object, the pyramid to be the second, the cube the third, and finally the cylinder. And that's the order I want them in. I then need to group them, so I'm going to do that now. Hold down my option key G to group them into a null. That's ready, so I've got my objects grouped as they should be. So let's go back to our circle, and what we'll do is make this minus 45 degrees, in fact minus 90, so that we start next to our cone. Okay, that's great. So that's all the objects set up, and now we can think about Espresso. We'll bring in a null, call it Espresso, give it the Espresso tag, and we've got the window open and we're ready to start work. Now, just make it a little bit smaller initially. We need to bring in all of our objects, so we'll grab a hold of these, bring them in, and we also need the sphere. Bring that one in there. And we can just place these however we like. Doesn't matter about the order really, but we'll just place them like this. And at the output stage, they all need global coordinates, or global position, I should say. Just global position across the board. We could probably use position with the sphere, but for what it is, I'll just make them all the same. Okay, great. So we've got that little part sorted out. Moving on from here, we need 4 distance nodes. And it's a shame that we can't just put these into a hierarchy and just feed them into one position distance node, I beg your pardon. But you can't, unfortunately. It just doesn't work like that. So we've got to bring in 4 of these. So we've got our first one. And what we'll do with our cone here, we'll plumb this into input 1 and our sphere into input 2. And then we'll get a result at the output stage. Let's just see what we get so that we can make a note of the number, because we'll need that a little bit later. Okay, so we're getting a distance of 30 between these 2 objects, and we'll get the same when we pass each of the others. So 30 is a key number, so bear that one in mind. We'll just take that away for now. Let's copy another distance node and get this one plumbed in. So this time it will be the pyramid into input 1, the sphere into input 2, the cylinder into input 1, the sphere into input 2. Just make the window a little bit bigger. And finally, the cube into input 1 and the sphere into input 2. And that's our distance nodes all set up and ready for the next step. And that will be to bring in 8 compare nodes. Let's do the first 2, so we'll get those set up. What we've got to do is plumb the output of the distance node into the input 1s. And then we'll sort out our functions and input 2s. So our first compare here, we will say, is greater than. Now, the reason we're doing this, you'll see in a moment, we'll say greater than 29. And, oops, just hit that. And with our second one here, we'll say less than. And it will be 31. We can't simply say, or have one compare and say is equal to 30, because when this is animated it won't be accurate enough. So we've got to allow a window of opportunity. So we've given it a plus or minus 1 unit. So between 29 and 31, that will work fine. And that's why we're having to do this. So let's copy, drop these 2 down here, place the output of our second distance node in those 2. Just make the window bigger again, and we'll move these down just to make things tidier. And then we can copy again, so command drag, plumb this one into these 2, and then finally another command drag. Just move these up, hit H once again so that we can see everything. And then plumb this into here. And just tidy things up a little bit more. Okay, that's looking nice, H, so that we can see everything. Okay, so that's the next step of this complete. Moving on from here, we need 4 bools. So let's bring those in. And the function will be AND. We don't need to change that because we're interested in being between these two values. So we can plumb the outputs of these two compares into this one. So when we're between, well, greater than 29, less than 31, both of these outputs will be 1. Both the inputs will be 1, and thus this output is going to be 1 because it will be true. Everything will be true. So let's do the same here. That gives us that one. And our final one. And that's the next step complete. Now, to finish this part of the algorithm off, we need yet another bool. So we'll command drag to copy this one, give it another couple of inputs, and then we're thinking about its function. And this one needs to be an OR. Okay, so we've got that worked out, and then all we've got to do is plumb these into the inputs. Okay, so when any one of these is true, this will be true. So what's happening here is that if we just move this over, so whenever our sphere is within a certain distance of any of these objects, the output of this is going to be true because one of these will be triggered. So that's what we're doing there. So as I said, it is quite involved, and it's simply because the distance node won't allow us to work with hierarchies, and it's a real shame that that's the case. That's something I hope Maxon do some work on at some stage, because it really does need to work in a sort of more efficient way, but it's just the way it is at the moment. You can't do anything about it. But anyway, we will move on from here and take a look at the next step. The next node to bring in is the all-important reference node, so we'll get a hold of one of those. And there it is. Now, how does this actually work? Basically, we need to pull in this null and give it an object port at the output stage and connect this to the instance. That's the first thing we need to do. Now, this is not the actual object that we're interested in. We're interested in its children. So this works it does work in a similar way to the hierarchy in the way that it references things. But the path here, that actually encourages you to place something in here. And it uses the same conventions as the hierarchy. So we can put down and next. We can also use P for previous, and we can use U for up. So we can move up and down in this hierarchy of objects here using this path. What we're actually going to be doing is using this the bool here to control a monoflop. That's what we're going to be using it for. And we're going to be using the monoflop as a counter, and then we're actually going to be using a Python node to feed this path. But don't worry about the Python, it's only a couple of lines that we need. It's really, really simple. But that's what we're going to be doing. And then once you've got this path, once that's got something in it, it will actually output whichever of these that we choose. And then what we need to do is actually feed those back into the null. So we need to put an object port at the input stage, plumb this into here, and then we can get whatever information we want. I mean, we can get coordinates, but what we're actually going to be using is the name. And we're going to be passing that to a text spline. So that's how we're going to be using this reference node. So we've got that little part over there. We'll just put this to one side for a second because we've got other stuff to do before we get there. Now, as I just said, we do need a monoflop, so we'll bring one of those in. We will give it a reset port at the input stage because the only thing we want to use is the counter from the monoflop. We're not interested in using it as a timer. So the output we can plumb into the trigger, and we must set the monoflop up as a one-shot monoflop in the mode. And then we can think about what we're going to be doing with the reset. We'll bring a time node in. So we've got one of those. As per usual, I'll just put a frame port in there and take the time away. Probably don't need to, but it's just force of habit. And then I need another compare. its function will be equal to, and input 2 will be 0 because we're going to be using this at the beginning of the animation to reset the counter of the monoflop. So that's what we're using that for. It's just a simple reset. Okay, fantastic. So we've got that part complete. We can now think about where we're going from here in order to get this all working. And as I mentioned, we do need a Python node. So we're going to bring one of those in. So script Python. And then we can think about what we're going to do with it. Well, for a start, we're going to delete the ports and give it some new ports. At the input stage, we need an integer. We'll rename this count. And at the output stage, we will give this an integer and rename it, or rather, sorry, not an integer, I beg your pardon. It's not an integer, it's a string. We need a string, and we will rename this path. I'll open the Python editor because we've only got a couple of lines to do, so there's no point in switching to a script layout. We can remove this line and we can say p underscore string is equal to, and this will be a tuple, so we'll just single quotes we'll put there and then put d, single quotes again, dn, single quotes once again, dnn, and finally single quotes dnnn. And those are our path strings, and they will allow us to go from our null down to give us our first object, which will be the cone, down next the pyramid, down next the cube, and finally down next the cylinder. So that's that side of things sorted out, and then we can simply say path is equal to, and it will be p underscore string square brackets count. And that's as much Python as we need to do. We'll just hit the execute button, make sure that appears down here, and then we can close this up and we can connect things. So we can connect our count to the count input of the Python node, and then the path output can be connected to the path input of the reference node. And that's connected everything up. Now, the next thing we need to do is bring in a text spline. So we'll bring one of those in. We'll set it to align center or middle. So that's in the correct place. And then we can change the font. And I'm going to use Lemon Milk Pro because I like it. You may not have that one, but you can use any font that you like. There we go. Where are we? I've got to go down here for Lemon Milk Pro. There it is. Fantastic. So we've got the font. I'm going to make that about 40. And then it can be set to 45 degrees. We can also drop this into an extrude, and the extrude will make 10 in the offset, and in the caps we'll give it a small amount of rounding. We'll just say 1, and that makes it look quite nice. So we've got that sorted out. The next thing to do is bring the text spline into the Espresso editor, and at the input stage give it a text spline input, and then we can connect the output of the null. And now we've got it set, and it says cone, so it's doing the right thing. So that's all working as we need it to, and it's all looking good. The next thing to do then, just to finish off, is to add some keyframe animation to the align to spline. Now, the position is obviously what we're going to be working with, so at frame 0, which we are at, we can record there, and then we can skip through to the end to 90 frames here, make this 100%, and record there. Let's go back to the start of the animation, just play and see if we get anything. And we do. Yeah, we're still getting a null at 0. What I'll also do, I'll just go into my F-curve, timeline F-curve here, and we'll make this linear, and that will give us a better result. Let's just see what we get now. Okay, and we're not getting the null in there now. Fantastic. So you can see that it's all working. And it's doing exactly what I said it needed to do. Fabulous. So that is how you go about creating this particular scene. Now let's just hit H so that we can see the whole expression. And there it is. That's what you need to do in order to do it. As I say, unfortunately, we have to do all this work over here. I just wish we didn't have to do anywhere near as much of this. But the way things stand at present, that's what we have to do. But the rest of it is pretty straightforward, really. You know, just triggering a counter, and then with the Python node here, just bringing the correct string to the output here and passing it to this reference node's path in order to choose the correct object at the correct time. That's all it really does. It's just a synchronization thing. That's all it is. Perfectly straightforward. But that's your reference node, and that's how it actually works. So it's a curious little node. I mean, as I say, I've never used it before, never used that in anything. Just stumbled across it and thought, well, let's see what it does. And, you know, this seemed a sort of reasonable way to sort of illustrate how it works. I mean, there's plenty of other things you can do with it. You know, get your thinking cap on and see if you can come up with an idea for incorporating it into something. But anyway, that just about brings us to the end of this particular tutorial. So as always, I really hope you've enjoyed doing this one and that it's given you some more ideas for things that you can incorporate into your own projects. And if you have enjoyed the video, then please give it a like. And if you haven't already, please subscribe to the channel, leave a comment, and of course, ring the bell. And wherever you happen to be on social media, please, as I always say, please do share this video, because all this good stuff really does help keep the channel moving in the right direction. But anyway, that just about wraps this one up. So I'll see you very soon on the next tutorial.